Hello students, Dr. Vance here. So still on signals and systems, treating Laplace transforms. Let's find a solution to this question. So here x of t is equals to e exponent minus at into u of what? T. Okay, so the first thing I think we should do is to plot our unit step signal, which is this u of t. So here we can just say that this is 0. Here is what? U of what? T. Here is what? Let's say x of what? T. Here is what? T. Okay, so it's going to go this way. Okay, so now here, let us just briefly find our what? ROC. So ROC is such that we have here, the graph is from what? 0 to infinity. So straight away I'll bring 0 and then I'll bring what? Infinity. And then we actually know that this ROC is actually given by here minus infinity to what? Infinity. Okay, we have x of what? T into what? X of t into e exponent what? Minus sigma t. Okay, minus sigma t absolute. Okay, minus sigma t absolute into what? Into the t, which is supposed to be less than what? Infinity. Okay, so this is the formula that we have for the ROC. Okay, so now implementing this formula here, I know that my x of t is what? E exponent minus at into u of t, but u of t is actually what? It's actually 1. So any number multiplied by 1 is that same number. So I'm going to have e exponent minus what? At here into what? Into e exponent minus what? Sigma what? T here into what? Into the t. So this one will give me what? 0 into what? Infinity. Okay, so I'll have e exponent what? Minus out. Okay, I can say that sigma. Okay, I can say that sigma plus what? Plus a. Okay, sigma plus a into what? T. Okay, then I can write here what? The t. All right, so basically I can have this one, and then when I have this one, it's supposed to be actually less than what? Infinity from here. Okay, from here it's supposed to be less than infinity. So now if it's supposed to be less than infinity, then by mathematical principle, what I have to deal with is the sigma plus a. Is what I have to deal with. Okay, so but if you check the graph, this graph is lying at the positive side of the x-axis, meaning that the graph is what? In the positive region of the x-axis. Okay, so the graph is what? Positive. Okay, so if this graph is positive, then that means I'm going to have sigma plus a. Okay, which is greater than what? 0, because at this part of the graph it is greater than what? 0, where our u of t is what? Is lying. Okay, where our u of t is lying. All right, so now here I'm just gonna have this sigma plus a. Sigma plus a is greater than 0 because my graph is lying at the positive region of the x-axis, which is greater than what? 0. So it's greater than what? 0. And this one should actually give me sigma, which is greater than minus what? A, if a goes here. So basically here what I can say is that sigma is also called what? Real of s. Real of s is actually greater than minus what? A. From there I can just plot my what? My s plane. So this is my s plane. I'll write here s plane. Okay, and then here, okay, imaginary of s, and here is what? J omega, and here is what? Sigma. Here is real of what? Real of s. Okay, here is what? 0. So where is minus a? Okay, this place is what? Minus a. So here I can write real of what? S is equals to minus what? A. And I'll draw my broken lines here. Okay, where is my graph supposed to go? My graph is supposed to go what? This way, because here, because my u of t is what? Greater than what? 0. It is this place which is what? Greater than, it is this place which is what? Actually facing the direction of what? Of my graph. Okay, is this plane which is facing the direction of what? Of my graph. Okay, here my real of s is minus a. So the minus a I get should actually be greater than what? 0. Even though here and here is not greater than 0. Okay, what happens is that because my real of s is in the negative, that means that this whole area has to be actually be assumed that it's also greater than 0, so that I can have my Q of A greater than what? 0, as this one says. Okay, so here this is what is going to actually this is going to be the direction for my plane. Okay, this is going to be the direction of what? Of my plane. All right, so this is going to be the direction of my plane. So basically, your plane is your rail of S. Your rail of S. Okay, so your rail of S is greater than what? 0. And what is the value of your rail of X? The value for your rail of S is what? Minus A. So you show your minus A, and every place, and every place. So that this rail of S should be greater than what? Rail of S should be greater than minus A. So this is the rail of S. Which part of the rail of S is greater than what? Minus A. This place is what? Greater than minus A. This place is what? Less than minus A. So that it conforms with what I have here. Okay, so this place, this rail of S here is greater than what? Minus A. Here is less than minus A. My answer was greater than minus A, so I have to choose this region. Okay, so now that you have been able to choose your region, you just go ahead and find your Laplace transform. Okay, so to find your Laplace transform, L of what? T of X of what? T. Okay, which is equals to X of what? S is actually equals to summation minus infinity to what? Infinity X of what? T into E minus what? ST, which is equals to, in this case, my unit step is from what? Is from 0 to what? Infinity. Okay, it's from 0 to infinity. So here, I'll just write here 0 to what? Infinity. And then my X of T is what? E exponent what? Minus AT into U of T. But U of T is actually 1. So if it is 1, any number multiplied by 1 is that same number. So that means that I will still get what? E exponent what? Minus what? AT. Okay. Into what? Into this one. Okay. E exponent minus what? ST. D what? dt. Okay. So now if I have that one, then what I can say is that I can have 0 to what? Infinity. I can have E exponent minus what? S. Okay, minus what? A. Okay, so I can have S minus A into what? Into the T, which is equals to, which is going to be equals to 1 over minus 1 over what? S minus what? A. Okay, S minus A. All right. Should it be S minus A? Oh, okay, sorry. It cannot be S minus A, because if I say it's S minus, if I say it's S minus A, that means that negative 1 times S is what? Negative ST. Negative 1 times negative A will not give me negative AT. Okay, so negative 1 times what? Negative A. It will not be negative A. It will be what? Positive A. Okay, so that means that I must make here what? Positive. Okay, so here will become positive into what? E exponent what? Minus S plus what? A. Okay, minus S plus A. Okay, and this, the limits here are what? Are 0. The limits are 0. And then what? Infinity. Okay, so this one will actually give me here minus 1 over what? S minus what? A into what? Into E exponent what? Here I'll have what? Minus infinity. S plus A is positive here. Why am I saying S plus A is positive here? It is positive because you see that my graph, my U of T is lying in the positive region of the x-axis. And also, I said that sigma plus A is greater than what? 0. Okay, so that sigma plus A is greater than what? 0. So that means that if it is greater than 0, that means that it's supposed to be what? Positive. It's supposed to be positive. So now here, I'll have negative what? Infinity. So I'll just, S plus A is positive. This negative is what I've written here. This infinity is what I have brought here. Okay, then here, minus what? E exponent 0 minus E exponent what? 0. Okay, so basically this one will give me minus 1 over what? X of what? S is equals to minus 1. Okay, sorry, here is plus. See that it's plus here. Okay, it's plus here. Okay, it's plus here. So here it must be plus. So plus what? A. Okay, into what? 0 into 0 minus what? 1, which is equals to 1 over what? S plus what? A. Okay, so now X of what? S. Okay, into what? Laplace what? Transform will give us 1 over what? S plus what? A. And this one, the real of S is what? less than minus what? A. Alright, so that will be the end of this particular question. Alright, thank you so much. See you in the next lecture.